Welcome to Algebra, Linear Transformations. This lesson will explore several ways an equation can be changed or transformed, thus changing how it appears on the graph. Check it out. A linear transformation is a change in a linear function, visible in the change of the graph. This lesson will explore several different types of transformations. We start with this example in Desmos of the line represented by the function f of x equals 1 over 2x minus 2. Remember that f of x is another notation style used to represent y, a way of naming the function in a more unique way. The slope-intercept form being y equals 1 over 2x minus 2. The line representing this function is what you see here, passing through the point -2 on the y-axis, going up 1 and over 2 each time for the slope. Activating the second example in Desmos, f of x plus 2 shows a change in the position of the line. It moves up 2 spaces, which makes sense with the plus 2 added to the end of the original function. When we add 2 to the equation in slope-intercept form, you can see the new equation, y equals 1 over 2x plus 0, with the new value of b, 0, the new y-intercept, or point through which the line crosses the y-axis. The next example, f of x minus 4, shows another change in the position of the line. It moves down 4 spaces, again making sense with 4 subtracted at the end of the original function. Subtracting 4 from the equation in slope-intercept form results in the value -6 for b, the new y-intercept. The fourth function example is a bit different. This time, inside the parentheses with x is the factor 2, multiplication this time. This changes the slope of the line, causing it to swivel on the y-intercept. Applying the new factor to the slope-intercept form multiplies the old slope, 1 over 2, by 2, creating a new slope of 1. The y-intercept does not change. This next function example is just like the previous one. A factor of 6 multiplies the x variable. This also changes the slope of the line to 3, causing it to swivel even more. Applying this factor to the equation multiplies the old slope, 1 over 2, by 6, creating a new slope of 3. Again, the y-intercept doesn't change. The sixth function in these examples is a bit perplexing. Look at it carefully. It uses subtraction like the third example did, but it doesn't seem to be doing the same thing. Notice the subtraction is inside the parentheses with the x variable. This is important. In the third example, the -4 lowered the position of the y-intercept 4 steps. This graph doesn't do that. Instead, it goes down only 1.5 steps, not 3. What is up with that? Here is the effect of subtracting inside the parentheses. A -3 moves it to the right 3 steps. When we put this into the equation and evaluate, first distributing the 1/2 and then combining the constant values, the new y-intercept is at -3 and 1/2, which matches what you see. So, to summarize, when subtraction is inside with the x term, the shift is to the right. Look carefully at function number 7 and see if you can predict, based on the last example, what change will happen to the graph. If you thought it will shift to the left 2 steps, you are correct. It makes sense that if subtraction shifts to the right, then addition shifts to the left. Working through the change in the equation shows this to be correct, with a new y-intercept of -1. Function number 8 is something totally new, a factor of 2 in front of the entire function. Take a moment and think about this change. First, we work through the equation changes and see both the slope changes, and then the line shifts with a new y-intercept of -4. Function 9 is just like the previous one, but with a factor of 4. The slope changes to 2, and the y-intercept is -8. Function number 10 again is just like the previous one, but now with a factor of -1. The whole graph reverses from a positive slope to negative and negative y-intercept to positive. In this last function, the negative only affects the x variable, not the y-intercept. The slope reverses from positive to negative, but the y-intercept stays the same. To summarize, adding a value at the end shifts the whole graph upwards. Subtracting a value at the end shifts the whole graph downwards. Multiplying the x variable changes the slope, but not the y-intercept. Subtracting a value inside the parentheses shifts the whole graph to the right. Adding a value inside the parentheses shifts the whole graph to the left. Multiplying the entire function affects both the slope and y-intercept. Multiplying by -1 reverses both the slope and the y-intercept. Multiplying only the x variable by -1 reverses the slope, but does not change the y-intercept.